Hello, students. Before one can begin any type of project, one must understand the rules of said project. Basically, how are you going to organize your thoughts? If you do not have your thoughts organized, you wind up taking more time on it trying to figure out what it is you're going to do. Organization will allow you to process faster, more efficiently, and more accurately. And that's the same with even in big business, even in the game that your favorite company creates. And they go through this via a process that's known as SDLC, or System Development Life Cycle. What is a System Development Life Cycle? It's essentially a step of rules and implementations that goes from the creation of a product, from its very concept, all the way to its execution and then later maintenance. First up is probably the one that's going to be the easiest to understand. It's known as the waterfall model. What is the waterfall model? Well, the waterfall model is essentially a cascading waterfall. We go from the top all the way to the bottom. The top is step 1, middle step 2, then step 3, step 4, step 5, so on and so forth. Where you first start off with the requirements. And then once all the requirements are considered and finalized, then you move on to the next step, the design. Once you've finalized the design, you go and execute it. And once you've executed everything up to what you want to do, you go and test it. And when you're all done testing, you go and release it. Now, this model works under the assumption that once you're finished one step, you can just move on to the next. So this is more for simple projects. The extension of the waterfall model is what we call the V model, where not only does it go down like the waterfall, it then goes back up. So think of it like folding a book or a piece of paper in half. You have your setup and you have your payoff. These two things must communicate with each other. So after we implement something, we have a unit testing. If there is anything in our unit testing that we recognize something is wrong, it says that we've done something wrong with our detailed design. So we would have to go back in, change our detailed design, and then go back through re-implementation and then on to unit testing. Same thing if we go up to integration testing. Oh, if something doesn't integrate properly, like, oh no, this only works in Safari, but it does not work in Firefox or Chrome or Internet Explorer, oh no, we've done something wrong with our architecture. We need to go all the way back and change our architecture. And same thing with system and acceptance testing. Obviously, this is more time-consuming than the simple waterfall model. But think about it. Is this not what your video games today do? You play Overwatch, you play Fortnite, you play all these games that have constant updates and tweaks and changes with weapon damage and health and all these other things. You have time, money, and resources being dedicated to fixing and correcting and balancing and implementing new features to existing games. And building even further off of that concept, we have ourselves the spiral model. Now, looking at this graph at a get-go is very confusing, so let's start this off. Imagine up and down is your cost. The further you are from the center of the cross-section, the more expensive this is going to be. And the left and right line is your review phase. So you start off at the very center with your concept, and you figure out what your requirements are. And imagine each one of these 4 quadrants is its own different area. You have your objectives, you have your risks, you have your development, and then you have planning the next iteration. So you have your original concept requirements. And then once you get to about here, you have your first prototype. And from that prototype, you can then go and say, okay, what worked, what didn't, let's, figure this out. So what are the requirements we need again? Let's verify and validate it. Let's develop our plan. And let's go back around, and here we have prototype 2. Oh, and now it's a little bit better. So let's go, what are our requirements again that we need from this prototype? Let's go and verify and validate it again. Let's test the plan. Let's go all the way back around. And you can keep going on and on and on forever and ever, but eventually there will be an endpoint where you will actually implement this. So really the concept of the spiral design is that it takes all that going backwards in the V model and just makes it into prototypes. Of course, this is all done internally and adds more time and effort into the design process. And of course, you have to hope that all your testing was actually accurate. Something very similar to the spiral model, but probably less confusing to look at, is the iterative model. So you start with your planning. And when you plan, you have your requirements, as always, you have your design, and you implement it. Now, from that implementation, you can go two ways. You can either deploy it immediately, or you can verify what it is you've just implemented. And once you verify it, you can evaluate. Was this something we wanted to do, yes or no? And then you can go back and forth to your planning and going, okay, what's next? And keep going around the circle, so on and so forth, as ever many times you want, much like Spiral. But at some point, much like Spiral, you have to deploy. You have to go, here's our product, we're not doing anything else added to it. So Spiral and the iterative model both have the same general problem of feature creep. We've seen this happen with games where they just keep adding more and more and more and more and more stuff, and it becomes such a big, giant, bloated game that even if it makes a lot of money, it might not make a profit. So, going back, once again, the most important phase of any sort of project is how well you plan it. But what if you don't have any plan at all? What if you don't have any money requirements or time requirements or resources? What if you don't know who your audience is going to be? What if you don't even know what your game is going to be? Well, then there's this thing called the Big Bang model. Basically, from a central point, the Big Bang model spreads out everywhere. Someone might be making a racing game, someone might be making some little code that does something fun with trails of rainbows, someone's making a bullet sponge, literally, someone's making something else, everyone's making all different ideas, and then at some point you're all just coming together and going, here's what we got. Now we have different elements that we can Frankenstein together and make a game. This is probably how the world's first video game companies started. They were all hobbyists out of their garage. They were just tinkering with computers and then realized, oh, I can make this little block move. What can I do with it now that it moves? I can make it touch something. What happens when it touches something? Do I want it to warp somewhere else? Do I want it to push the object? Do I want it to bounce off? And eventually, through trial and error, they wound up making games. Now, there's more than just these 5 models that I've shown you, but the key takeaway is that there's positives and negatives of every type of model. Some of them are more rigid in structure and don't allow for much change. Others, have more process involved for implementing features or correcting mistakes, but could wind up more costly in the long run. What type of project you're working on depends on what type of SDLC you would wind up using. There's no such thing as one SDLC type that's above and beyond the rest. It's just the positives and negatives of each type, depending on the situation.